Hello friends, my name is Amit. Welcome to NDT and Quality YouTube channel. So friends, in today's video we are going to see about bond joints and brazed joints in ultrasonic testing. How is UT done for bond and brazed joints? So generally NDT is done for both these joints. But wherever it is a very critical part like aerospace industry etc., then NDT is also done for this joint. So generally liquid pertinent ultrasonic etc. method is used in this. So first of all we will see whether it is a bond joint or a bridge joint. What kind of design is it, and after that how do we have to do UT etc. in it. So if you work in aerospace industry or you are in any general industry in which bond or brace type joints are used there and you have to do NDT in it, then you can do ultrasonic testing in it. So in ultrasonic testing, we mainly use longitudinal wave. Longitudinal means that we use compressional wave. That means we do testing using straight beam probe. So its process is quite easy. You must have checked lamination etc. in steel weight. Similarly, we do UT in this. But here the design of bond and break joint is a little different. So for this, you may have to use other techniques apart from the normal back-Ullich technique. So which different techniques will be used in this, we will discuss in the video. So if you have not subscribed to our channel yet, then definitely subscribe to the channel. Share this video with your friends and colleagues too. You can take membership of the channel by using the join feature. This join feature is given to you next to the subscribe button. If you use the join feature in this, then I have made many videos of NDT level 2. You can access them. I have covered the entire syllabus in this. How to interpret code standards etc. Like there is an ASME course, there are some ASAT standards. I have also made videos of their interpretation. I have also made practical videos of NDT. Like ultrasonic testing of wheeled, right? So to get access to all these videos, you can use Joint Kitchen and support me financially. So here first of all we see that this is a brazed joint. First of all we will see. After that we will see the bond joint. How to do UT etc. in it. So longitudinal waves are used for inspection of brazed and bonded joints. So here longitudinal waves are generally used. Meaning it is compressional wave. You can use straight beam probe, TR or single crystal probe in this. Shear wave will not be used in this. So first of all let's talk about brazed joint. Where is brazing used and what type of joint it is. So brazing is a common process for joining sections of small diameter metal tubing and certain other small metal parts such as electrical contacts. So brazing is done in electrical contacts etc. as well. Apart from this, the beige metal here is a part with very less thickness. Its thickness is very less. Or if you want to join tubes etc. then there are small diameter tubes. You can also join these tubes in this. So it bonds two pieces of metal by means of metallic filler that is melted and then flows into the space between them by capillary attraction. So here we have to join two pieces and in this a metal filler metal is used. So this filler metal will melt and fuse in the space between the two joints. So it will go in the middle because of capillary attraction. So when we do PT etc., in LPT liquid penetration testing, capillary action is the main principle. PT is done on its basis. Right? So in the same way, in this brace joint, which is brazing, capillary attraction also happens. You will have two joints like this. Okay? You fill the filler metal in between them. So the filler metal melts and due to capillary action, a bond will be formed here in the middle. This is your brazing. Okay, this is your brazed joint, it is ready. Okay? So this is how it works. How do we test it now? If the wall thickness permits clear separation between back wall echoes, the joint can be examined using standard procedure for lamination. Okay? So here your wall thickness is such that you can separate the back wall from it. That means you can see the back wall separately. Suppose, how do you check lamination as per our standard procedure? You can check the joint in the same way. So I have already made a video of lamination. Okay? I had posted it about a month or two ago. So you can see that video. Okay? So just like here, suppose your joint is ready here. So on the upper side here you have to keep the probe. I have mentioned it in green color. Okay? And backalico, from here you get the backalico. So taking the reference of backalico, you do testing just like you check lamination, you have to do testing in the same way. It is quite easy. However, since the bridge metal separating the two bridge walls will have a slightly different acoustic impedance to that of a parent metal, the small interference echo may be present for good braze right. So here many times two metals are there okay, and the two metals are separated okay, like shown here in the figure below. This is one metal and this is the other metal okay, and in between here brazing has been done. This one is your brazing. So this kind of joint can also be designed. So in this case when you have to do the testing, okay? So here the impedance, the acoustic impedance will be different. This material is your bridge parent material. Sorry, okay? And the one below is also the parent material. But what you have applied in the middle is this bridge joint. Okay, I am showing this in the middle in orange color. This is your brazed joint, okay? So the acoustic impedance of the material of this brazed joint will be different from the parent metal. Okay? So in this case you will get the echo of this brazed joint. Okay? The echo you are getting here is the echo of your brazed joint. This is your initial pulse. This is the echo of your brazed joint and this is your back wall echo. Okay? So this is how you will see it on the screen. Why does it appear? Because the acoustic impedance is different. The acoustic impedance of your parent metal and the brazing material you have used as filler is different. Because of this you will see this echo. This is also called interference echo. Okay? So here this echo will always be visible on the screen. And suppose there is a defect here. Okay, that means there is a problem in the bridge joint. There is an empty space there. So what will happen in that case? The technique there is to look for increase in the interference echo amplitude. Right? So sometimes it happens that this bridge joint is not placed properly. Okay, so what will happen in this case? Here in the middle of the bridge joint, let's say, there is an empty space, some empty space left. Like porosity, or cracks. Whatever, okay, or lamination. Sorry, it will not be lamination, but there are cracks, porosity, or any empty space left. Cavities left. Okay? So, what will happen in that case is that the echo, the sound from here, will reflect and come back. Okay, and a lot of sound will come back. You will get good quantity sound. It will come back after reflection. So in this case, you will get a big echo like this. Okay, generally, when you do scanning, you will get a small echo, the echo of the bridge. Whereas in this case, you will get such a big echo when there's a problem or cavity in your brazed joint. Okay? So in this way you will know that there is some indication here. If the two braze walls are too thin to permit clear bag echoes, a multiple echo technique can be used. Okay, here there's a multiple echo technique, you can use that too. We will see the bonded joint in which multiple echo technique has been used. Even in the video that I had made on lamination, I had also told you a practical using this multiple echo technique. Okay? So you can see the video on lamination. There was a theoretical part in it and I had made another part. In that, I had also told how to use this multiple echo practically. So the part which is of lower thickness is thin thickness. Right? Meaning it is a part with less thickness. So at that time you can use this multiple echo technique. Okay? So as we have discussed in lamination checking video, you can see in that video we have discussed this multiple echo technique. Okay, here also we will see this technique in bonded joint. See bonded joint, this includes metal to metal glued joint. Right? Glued joint is written. It means with glue or any adhesive, then this metal is joined with adhesive. And metal to non-metal glued joint. Right? So it can be metal to metal joint or it can also be metal to non-metal joint. Both types of joints will be seen here. This is called bonded joint. Okay? So here for example there is rubber blocks bonded to steel plate. Rubber blocks have been joined with steel plate. Rubber means non-metal and steel both have been jointed. The technique used is a multiple echo technique. So if you want to do UT in this, then you will have to use this multiple echo technique. So see how it is. Each time the pulse reaches a bonded interface, a portion of the energy will be transmitted into the bonded layer and absorbed. Okay? So here, assume that this is your metal. Okay? And this is your rubber. This is the surface of the metal. This one is metal. And this whole part below is your rubber. Okay? You have placed a bonded joint of metal on top of the rubber. Metal is pasted on it. Okay? So here, suppose this is position 1, then what will happen in it? As soon as you place the probe above and the sound from here will go in this direction. So the acoustic impedance of both the materials is different here. Okay? So you will also get interference, echo, etc. in it 100%. But here your skin pattern will be, if you are using multiple echo technique, then you will get to see the skin pattern like this. In this, the range that you take on the basis of thickness is quite high. Okay? You take a range 10, 15, 20 times more than the thickness. So this is the kind of pattern you will get to see. There's a lot of echo. Right? The screen is like this. You will get to see a lot of echoes like this. Okay. So in this echo, if you join peak echo, then you will get to see this kind of echo. Like here there's a cow like this. Right? So this is a technique in which you have to see the decap pattern. You have a good bond. That means this position A is position 1. There is no defect in it. Okay? So here you will get to see the decap pattern like this. Okay. So what will actually happen here is that most of the sound that you reflect will get absorbed in the rubber etc. material. Whatever sound comes back, you will get to see this pattern of it. Most of the sound is absorbed. Each time the pulse reaches an unbounded layer, all the energy will be reflected. So the unbonded layer is where there is no bonding, where there is a defect. Okay, so what will happen in this case? Like here, number 2 is given. See, this is the position of number 2. The metal here is unbonded, meaning that there is no bond. So in this case, the sound will almost reflect from here and come back. Meaning a lot of sound will come back. Okay? So this echo that you are seeing first, more sound than that is coming back. So here in this second figure, you can see that a lot of sound will come back and you will get to see a lot of echo. Right? So in this way the decap pattern changed. See, a lot of sound came back and you get to see a lot of echo. Why did this happen? Because it is unbonded. The material here is unbonded. There is some cavity there. There is no bond there. There is some empty space. Okay, there is empty space. Means there is air there. Okay, there is an air gap. which means the acoustic impedance has changed again. And the acoustic impedance of air is very low, right? So in this case, the sound that you get will reflect back a lot. So the mismatch of acoustic impedance here will be very high. Okay. So if we look at the multiple echo pattern for a good bond, the decay will be relatively small because of the energy loss at each multiple echo into the bond. So this decay pattern here, you see, is the decay pattern of a good bond. So it has a short decay pattern. This way it is very short. Okay? A lot of area is empty here. Okay? However, for an unbounded layer, each multiple echo will be slightly bigger. Okay, this is an unbounded layer, meaning where the bond has not formed. Talking about this position number 2, there is a decay pattern here. It is very long, this is a decay pattern. Okay? Because there is no interference loss and the decay pattern will be significantly larger. So, the interference loss here, the loss that was happening in the rubber. Okay, the absorption that was happening in the rubber will not happen in this case. This is the second case where you have any indication there. Okay, so in this case you will get a decay pattern larger. You will get to see a long decay pattern. Okay, the figure above shows a good bond, meaning position 1 shows a good bond. And poor bond means position 2. So this position 2, this second position will show echo pattern like this. Okay? So in this way this is a bond joint and ultrasonication is done in it as a bridge joint. Generally, the strength of this joint is very low. So these joints are used less in high pressure or high temperature equipment or services. But still there are many such services in which these are critical services actually in which brazed and bonded joints are used. So you have to do net in that. Okay, so ultrasonic is an option. You can do ultrasonic testing in it. Okay, so UT etc. is done in this way. I hope you have understood this video. If you have any doubt in this, then you can ask me in the comment box. Okay, thank you.